There. I have to hit start record 4 times for it to work. Now, I want you to put beside Unit 3, I want you to write autopilot.
I already got that written down.
I know, yeah, well, you're very good, but some people, it takes 4 or 5 times for me to say it. I have to repeat myself 4 or 5 times. All this will be due at the end of the semester. Okay? Now, what if you have questions? I want you to continue to send them to me. We're going to jump to Unit 4. Now, there's 2 reasons I do this. The 2 reasons. 1, if you come back and take Math 120 and 103, either one of those, this is your first unit right here. Okay? Did y'all just hear that?
Yeah.
Okay. If you take Math 120 and 103 in a future date, this is your Unit 1 test. So that's one reason I teach it. The second reason I teach it is because this is more applicable to what you'll be going into your jobs than learning some of this stuff. So, but basically between the 2 units, this one is the most important, okay? That's why I want to go ahead and get to it. And I'm putting off the last unit because I think most of y'all know what a stop sign looks like, okay? I think most of y'all know what the Pentagon looks like. Mr. Robinson, do you know what the Pentagon looks like?
I do not.
Okay, you don't? Okay, well, Pentagon, where the Department of Defense is?
Oh, you said Pentagon?
Yeah, what does the Pentagon look like? It's got how many sides? 5 sides. Pentagon, it's got 5 sides.
Yeah, I thought you said something else. I thought you said something with M in it.
That's fine. Okay, what is a stop sign?
An octagon.
And how many sides does an octagon have?
8.
Octopus, octagon. How many sides do you think it has? So I'm not going to sit here. Octagon has 8 sides because you're thinking of Squidward. Somebody said 6. That's Squidward. Squidward's only got 6 legs. Squidward is a mutant between an octopus and a squid, okay? It really has not been determined which one he is, but he has 6 legs, so he is a squid. He's not a octopus. All right, but he has a head like the octopus. I guess it looked better on the cartoons to have a head like the octopus. He's one of my favorite characters. Him and Plankton. Plankton is my favorite. Okay, but we're going to go to Unit 4. Now, this is what I want you to do. I'm going to open up all the homework and the tests until the last week of class. All right? You send me questions as you have them. At the end of Unit 4, I will cover any questions that you send me. The reason I'm doing that is because instead of having all of this to go over, maybe I'll only have 2 sections to go over because y'all understand the other sections. You see where I'm going with this? In other words, most of you will have the same questions. You're not going to have the question, what does an octagon look like? Y'all all know what an octagon looks like. It looks like a stop sign, all right? Or a pentagon or a sexagon, whatever it is, all right? You know what the Pentagon looks like. You know what a square looks like. You know what the rectangle looks like. I'm not going to sit here and go over things that you should have learned back in K through 6, all right? What have you not seen? There are people that have not taken high school in 115 years, that's what they think, that have not seen probability and statistics. So I think it's more important to go over what you've not seen than what you have seen and maybe have forgotten, or you have seen and you have not forgotten. You see what I'm saying? Those are the 2 reasons I'm going to do this. So we're going to start on these sections down here. So I want everybody to make a note. Hold on a second. How do I get down? I got to use the mouse. I want everybody to make a note that we're going to go over sections 11 and 12 in the next few weeks. Okay? 11.1, 11.2, 12.1 through 12.4. Now I'm going to cover this first. I'm going to cover chapter 12 first. So everybody write that down. We're going to do that first. And then I'm going to cover 11.1 and 11.2, and I may cover even more of chapter 11 for your future purposes, okay? So does anybody have any questions?
No, sir.
All right, let's start on chapter 12. Now, let me shut down the handy dandy. I'm just going to go to the whiteboard. And
I thought we were
talk
doing
about,
like questions that we sent in today.
Oh, yeah, we need to do that too. I'm sorry. Thank you. I'm just not used to y'all sending any questions in, so
Well, I sent you two that I'm confused on.
I will be glad to go over them. Thank you for the communication. Math 155.
You have a work email.
Okay, I'm looking. There they are. You sent them Wednesday. Okay. Get rid of these stupid missing attendance. Things get on my nerves. Just give somebody a job. All right, 6.4, 43/9 and 10. So here we go with /9. I'll tell you if it's a test question or not. It is a test question,
Oh, yeah.
I think.
I
What?
couldn't figure that one out either.
All right.
Yeah, I'm
so,
not the only one.
Okay. So we only got 2 losers in the group. Just 2 losers that can't do it.
Apparently so.
Okay. All right. And probably 6 or 7 that probably didn't even try. All right. So S varies jointly as I and the square of T. So S varies jointly as the square, as jointly as I and the square of what? Okay? Now, you could read that as the jointly as I and the square of T. You might think that I and T is squared, but right here is where they cut it off. And they're saying S varies jointly as I and the square of T. So T is squared. All right? So S is 20. So that's part 1. Part 2, S is 20, okay, I is 8, and T is 10 squared. So I got to finish this. I got to find K. So 20 is equal to K times 2 times 4 times 2.2 times 5 times 2 times 5. I'm just doing this because I'm going to divide by all of that. So now I've got 2 times 2 times 5 divided by 2 times 4 times 2 times 5 times 2 times 5. And what happens to 2 of the 2's and 1 of the 5's?
Cancel.
Cancel. So I'm going to cancel this 2 with that 2. And that 5 with that 5, and this 2 with that 2. So somebody do the finishing.
2.4 and 2.5.
So what? That's 2 times 5, sorry. Okay, so that's going to be 2 times 4 is what?
8.
8. And 8 times 5 is what? 40, Hubert. So K is equal to what? 1 over 40, Hubert. Okay, so now I take part 3 and rewrite S is equal to 1 over 40 times I times T squared. And I'm just using the parentheses just so I can plug in next. That's why I did that. Okay, so you need to look and see which one it is. I don't care about that because we're going to do part 3. And this is part 3 right here. That's part 3. S is equal to 1/4 times 4 over 1 times 4 over 1 squared. And what happens to the 4 over 1s right here? What happens to those?
Cancel out.
They go out. And S is equal to what? 16. So let's check and see if I have any idea, clue what I'm doing. So I got kit squared, right? Lord, it's a miracle. What movie does that come from? Shawshank Redemption. You remember when he disappears and the warden walks into his room?
What movie?
Shawshank
Oh, yeah.
Redemption.
I haven't seen it.
You should watch
Lord, it's a miracle. Man up and disappears like a fart in the wind. And he did. He was in his cell all night, and then he just disappeared. Just disappeared. Lord, it's a miracle.
this. Morgan Freeman and
Yeah, Morgan Freeman is a great actor. 16.
Yeah, it is.
Check all. It's wrong. I have no idea what the answer is then. $1.6. Have I got a decimal wrong somewhere?
No.
I know decimals.
Yeah.
I don't think so. Okay, somebody check my numbers up here. I'm going to erase this, and I want you to check me.
It's 1/40.
Oh, thank you. I put 1/4. My bad. Right here. Y'all didn't even catch it. I didn't either. Right here. 1/40. Let me erase that. My bad. Made a mistake.
Fired.
I didn't make the mistake. It was because of the projector was running too loud. Okay? Because you're not supposed to take, you're not supposed to admit you made a mistake or didn't do something right. You're supposed to blame it on somebody else. So that would be 4, and that'll be a 10 right here. So let's take the 1/10. So S is equal to 1/10 times 4 over 1 squared, and that's equal to 16/10. And when you divide by a base of 10, you move the decimal how many zeros to the left. So it's equal to 1.6. Thank you, Mr. Phillips, for finding my error. Thank you, Mr. Phillips, for finding my error.
No problem.
There. It's called a response, okay? When somebody tells you something, you're supposed to respond. You know what? I'm going to tell y'all right now, y'all going to get fired when y'all in a job. When y'all get a job, you're going to get fired. Because you have to do this when you're in a job. You have to communicate. You can't text somebody at work and tell them, and you have to communicate. But you're going into computers, aren't you, Mr. Phillips?
Yes, sir.
Okay, you don't have to communicate. You're just going to be in a closet. That's what
Yeah.
you do. You're going to be in a closet programming. He's in the zone. He's writing code. 6.4, number 10. 43, number 10. Okay, the distance D that a rock falls. So let's go to D is equal to varies directly as the square of the time. Directly is k times what? X. So that's k times t. Anything else? I think that's it. So that's part one.
Apparently it's squared.
Oh, I didn't see that. Thank you. Okay?
But why? Why is it squared?
Right here. The square of the time. I didn't see that until y'all said that. I sat there and read it. I didn't see it. So y'all gonna have to, like me, take a dadgum highlighter, and whenever you see that word, you need to highlight it because I just read the dadgum thing and didn't even see it. The rock is falling. If a rock falls 400 feet is what? The distance. So that's this part one. And I hate to be repetitive, but this is the same way you're going to do it on the test. And these are test questions. So 400 equals k times 5 squared. Divide by 25. Now don't get a calculator out. How many quarters are in $4?
4.
16.
Yeah.
I guarantee you people reach for a dadgum calculator, but I ask you how many quarters are in $4, you tell me 16. So now part 3. This is part 1. This is part 2. And now this is part 3. So back substitute. D is equal to 16 times t squared. D is equal to 16 times 9 squared. D is equal to 16 times 80 what? 1. Now I'm going to try to do this in my head. 8 times 16 is 128 with a 0 on it. So that's 1280. 1280 plus 16 is 1296. Somebody check my math.
Okay.
Say again.
It's 128.
Darn, how did I get that wrong? It can't be, because 10 times 81 is 810 feet. Did I do it wrong again?
Yeah.
I don't.
It says directly. Let's see if I got it right.
Yeah.
No, you're right. You're right.
Y'all gonna give me a complex.
Sorry about
I'm gonna have to wear sunglasses in the building. The rock will fall 1,296 feet. What is this? Feet. And I feel good about myself. My son and I were somewhere. I think we were at Lowe's or somewhere this weekend or Friday, and we were walking through, right behind the registers, and there was this guy that walked by, and okay, we were way in the store, so it's not like we were at the front doors, okay? We were like, in the middle of the store, and he had this mean look on his face, and he had these mirror sunglasses on, and he had no intentions of taking those things off. And my son was walking, and we were walking this way, and he was walking, and my son just said out loud, he said, "The sun sure is bright in here, Daddy." I said, "Yeah, it sure is." I mean, what was I going to say? I just said, "Yeah, it sure is." Do not do that, guys, because you look like an idiot. All right, next question. Oh, we're done with that, so now we can get started. If you got any questions, I've given y'all plenty of time to go over them, so Anybody, does that help both of y'all on that one? On those two questions? Ms. Johnson and Ms. Phillips?
I think so.
Yeah.
Yeah, thank you for the communication.
Welcome.
Let me put my crowbar down because I had to pry it out of you. Okay, so let's get back to statistics. Somebody tell me what statistics is. What is statistics? I need somebody to interact with me. Okay, nobody's going to interact with me. I don't know why. You know what I should do? I should just write on the board and not talk. You should give y'all a little taste of your own medicine. What did you say, Mr. Robinson?
Is it something like data almost?
Yep, you're dealing with data. There's two. Somebody needs to look this up because I'm not an English professor, but there's when two words are exactly the same word, but they have two different meanings. I don't know what that is. All right. Capital S is the collection, calculation, and interpretation of what?
Numbers, data.
Data. Yep. Little s, statistics, is a parameter, and I'm going to put, no, I don't want to put parameter. Well, I'm going to put a variable. Let's put variable. Variable used with the sample. And we're going to talk about that later. Okay? So, when I tell you that we're talking about statistics, and when we're talking about statistics as a broad subject, we're dealing with a capital S. If we're talking about statistics like, and I'll just give you several examples, the mean and the standard deviation. Those are two parameters that are used with the sample, and they're called statistical variables, or statistics with a little s. All right, that's supposed to be a T right there. Now, what type of statistics are they? Well, there are descriptive statistics, and then there's inferential statistics. And what I'm going to do is I'm going to pull up, because I want to make sure I cover everything, because sometimes I go kind of fast with statistics because I assume that everybody is fluent in statistics because they've had 2 or 3 courses in it, like in high school, because for some reason they only want to teach you high school statistics. They don't want to teach a lot of algebra and stuff like that in high school. They just want to teach you statistics. So I'm going to make sure so I can use this. I'll shut up.
I only had one class.
You only had one? I'm surprised I don't make 3 out of them. But anyway.
I never took a statistic class at
You're
all.
kidding.
Uh-uh.
Well, I've had students come and say, we didn't have to take a math our last 2 years. I said, why? Well, we took statistics in 11th grade, and we didn't take a math 12th grade year. And I'm like, and people wonder why they do bad on the placement test. That's why.
I think it's in 2004, 5 time frame.
What'd you say, Mr. Robinson?
I haven't took it in like 2004, 2005.
Okay, well, see, there's some people that are probably a little bit rusty. So let's go ahead and look at I want to make sure I cover everything because sometimes I get kind of fast. So here we go. There we go. Statistics, blah, 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 blah. 2 main branches, descriptive and inferential. Descriptive is when Miss Johnson goes out to the parking lot and counts the white cars versus all the different other color cars. Okay? What is Miss Johnson doing? She's actually what? That means I won't.
Survey.
Interact. She's going out and actually what?
Counting.
Organizing.
Counting. She's organizing. She's putting it down on a piece of paper. She's going to calculate whether the percentages, whether, the probability or whatever. The whole point is she's doing all the what? She's doing all the work. Okay, that's what descriptive statistics is. The collection, that is the main part. The collection and the what? Organization. You do that. All right? Let's say Mr. Robinson goes out and wants to decide, if the, what county you live in, Mr. Robinson?
Oak County.
Okay.
Walhalla.
Okay. Let's say that he wants to find out how many drunk drivers were arrested or in a wreck in Walhalla in 2017 or so far in 2018. So he goes to the hospital and then he goes to the blah, blah, blah. Has he done the statistics or is he just using other people's numbers?
He's using other people's numbers.
He's using other people's numbers, so he's using inferential. Okay? When you're using other people's information, you're using inferential. This is a very, very, very popular question on test. All right? So you need to write it down and you need to make the distinction between the two. All right? Question on that? There's an old saying about statistics. There's the truth, there's lies, and then there's statistics. All right? And I don't know what the quote. Somebody Google it for me. It says something about that. It's a quote that says there's lies, there's truth, and then there's statistics. I can't do it verbatim, but sometimes people use statistics to what? To influence other people. Okay? We see this in a lot of different ways.
Cigarette ads.
What?
Would be like cigarette ads to
Yep.
make you stop.
Exactly. We see that with cigarette ads. We see it, especially back in the day, back in the 60s and 70s, the media just did a lot of the cigarette companies did a lot of bogus research, and they presented it, and everybody was saying, "Oh, everything's fine, everything's fine. I'll smoke 3 packs a day, and everything's fine." And then they found out that it wasn't true. You also have political. You have a lot of political statistics that are not very true.
Crime.
I could say again.
Crime.
Crimes.
So now
Yep.
they go from door to door and do surveys. Everybody's not honest.
Exactly. You have a lot of that. So that's why I wish I could remember the quote.
It's, there are 3 kinds of lies. Lies, damned lies, and statistics.
Thank you. Thank you so much. That's it. Okay. All right. Well, remember that because it's true. And we're going to be talking about, and one of the biggest terms that we talk about is bias. And as he said, with the cigarette companies, the same way. With the way you word a question. I remember going through a class at Clemson, and I had to actually, the whole class was nothing but how to write questions. I could write you a question, and I could say, "You're not going to vote for Mr. Smith at the next election, are you?" And have yes or no under it. Is that a biased question? Yes, it's a biased question. The question should say, who are you going to vote for in the next election, and leave a blank or have 3 choices or whatever the case may be. You don't lead with a question. Like Mr. Robinson said, sometimes people come to your door, and if they are legitimate, they may ask you a question that's very leading. And you should say to them, "That's a very leading question. I'm not going to answer that." Because it's a bias, whatever, whether it's about collecting trash or whether it's about something to do with the local government or whatever the case may be. You don't need to answer questions that are leading. Because like you said, there's lies, there's damn lies, and then there's statistics. So you got to watch out for that. All right. What is the population? The population, write this down, is always your biggest body. Okay? Population is always the biggest body. If I want to find the average age of students at Tri-County Technical College, then the population is any student at Tri-County Tech, whether they go to the Sandy Springs campus, whether they go to the Anderson campus, whether they go to the Pendleton campus, Easley campus, or whatever. The population is the big picture. The sample, if I decided to use a sample, would be the Anderson campus. And I would survey all the students at the Anderson campus, and I would use that as a sample. The sample is always the smallest of the two. The largest of the two is always the what? Population. Now, why do you concern yourself with the sample? Because what are the two most important things in all of our lives? That's not rhetorical. In my life, in Mr. Robinson's life, Mr. and Ms. Phillips' life, Johnson, everybody in our lives, what is the two most important things that we think about?
Money and family.
Okay, money? No, not family. It's third. What's very important to us as far as money and
Ourselves.
what do we spend? In order to spend, in order to be with our family, we have to have what? Starts with a T.
Time.
Time. Money and time. Money and time is the two things that are most important to us. What do we do with our time, Mr. Robinson? If we have spare time, what do we do with it? We spend time with our what? Family. Okay, but you got to have that time first. Huh? What?
I said sleeping.
Okay, well that's your me time. Okay, and that's important too. But the whole point is the time is more important than the family, because if you don't have the time to spend with your family, you don't have the family. You see what I'm saying? So time is very important. Now, what does that have to do with statistics? What you are doing is you are saving time and money using the sample to predict for the what?
For the population.
For the population. Now, you got to think about the big picture. There are people, they're on national TV, and what is their business? Their business is doing what we're talking about right here. What are they? They're basically pollsters. They have businesses to where all they do is go out and they survey people. If you've watched any news, they do that. They're out there. There's people, I can name 5 people on my finger, and 5 people on my hand right now. The only thing they do for a living is they own a polling company. And they find out polls, mostly political. A lot of them are political, but some of them are for businesses. And they go out and business says, Michelin, I want to find out how many people use my tires, or our tires. Okay, pay me $10,000 and I'll go out and I'll sample the population and I'll be able to give you within 94%, 95% confidence level that this across the nation is who's using your tires. And they will do that. So we're not talking about, I'm using this to get in the next class. No, I'm talking about people make money doing this. All right. So a statistician, that's usually somebody that likes statistics that don't have a math degree. Usually that's a joke. Okay, a statistician wants to take the population, the sample, and predict for the population. Because it saves time and what?
Money.
For the client, which in this case I'm going to say Michelin or whoever hires the polling company. Some of your commentators that are on the news, All they do is poll people, whether they're talking about whatever subject they're talking about. Okay? All they do, that's their business. They poll people. That's why they're on the news, because they own polling companies. Okay? It's easy, it's for you to understand this. And well, Hubert, I'm not going to be a pollster. Yes, you're not going to be a pollster, but will you be presented things at your job? Yes. Okay? Let's take, for instance, last name again.
Carrillo.
Carrillo's going to beat up people. Okay? He's going to be a policeman. Okay? So he's going to beat up people for no reason. All right? So he's going to be presented those statistics every year by his, I don't know if they call them COs, but I'm going to call them COs because that's the only thing I know anything about. Their CO is going to present statistics every year on how many people they beat up for no reason. Okay? They have to be able to read those statistics. They have to be able to say, okay, I know what the X bar is versus the mu. I know what the sigma is versus the S. I know what the standard deviation is. I know what the mean is. You need to know that from a presentee's standpoint. Now, what if you are a department head and you're presenting? Then you need to know even more. So when you're taking the Math 155 Unit 3 or whatever I'm putting this in, Unit 4, statistics, or you're taking Math 120 or Math 103, no, you're not going out and building a polling business tomorrow. No, that's not what you're doing. What you're learning about is enough information to where you can either be presented this information or you can present this information in your work-related area. That's what this is for. So you have to have an understanding of some of these terms and definitions. Okay? A sample is a small group that predicts for the population. That's a very true statement. You have to write that statement down. That is a very, very true statement. And I'm not going to say statistician. I can't stand that word. Okay? When a person draws a conclusion from a sample, there is always the possibility that the conclusion is incorrect. Let me give you an example. Let's say I go, let's pick on Mr. Robinson. I like picking on Mr. Robinson because he's at the head of the table. All right. So Mr. Robinson decides he's going to he's going to the Amstar 14 Theater here in Anderson, and he's going to pull the movies for the last week for Nicolas Cage movies. Well, let's say a Nicolas Cage movie. That's the only, I would say John Travolta, but all his movies are good. So I'm going to just say Nicolas Cage. All right? And he pulls for the last week the ticket sales for the Nicolas Cage movies. Everybody with me? And he charts it. He charts it on Monday, 1,500 people saw a Nicolas Cage movie. Tuesday, 2,000 people saw a Nicolas Cage movie. Friday, Monday, Tuesday, Wednesday, Thursday, Friday, 4,500 people saw the Nicolas Cage movies. Okay? And he puts that on a chart. And he says, okay, now I'm going to run that with suicide rate this week. And he runs that with the suicide rates. He goes to the hospital, AMB, up here on Gringle Street, and he says, I'm doing this I want to know how many people died of suicide this week. And he puts Monday, 2 people, Friday, 16 people. And he says that because of the Nicolas Cage movies in Anderson, there's been an increase in Nicolas Cage movies, and there's been an increase in suicides that same week. So Nicolas Cage movies cause suicides. What did I just do? I just used statistics to say something that was full of what? Crap. It wasn't even biased. It was made up. Okay? It was made up. What did I do? I came up with an incorrect what? Conclusion. But I used statistics to back it up. That's why there's lies, damn lies, and statistics. Because you can use statistics to tell you that you have red hair and you have blonde hair. I mean, you can use statistics to tell you anything. So you've got to be careful when somebody presents you with a poll or a survey, you've got to be careful. What is a random sample? A random sample is a sample where everyone has the same what of being picked?
Equal chance.
Equal chance. This is what you need to highlight. And you don't only need to write 2 words for hold on a minute. Let me go through the Act of Congress here. Let me just hit the white. You just need to write down this right here. Oh my gosh. I'm just going to give up. I'm going to try this one more time. You just need to write down this for random sample. Now, I'm going to give you a scenario. Y'all know what a scenario is, right?
Mm-hmm.
You're not typing it in your phone to see what the definition of a scenario is, are you?
Not right
No,
now.
you're just texting while I'm talking. Is that right, Miss Phillips?
Yeah. Oh.
Okay, I'll remember that when you ask a question next time and I start texting. Okay? What is an equal chance? Let's say that everybody, I hand out a, what is it called? Sticky note? What's it called?
Post-it note?
Post-it note. I give out one yellow Post-it note to every student I have at the Oconee campus and here. And I tell you, give everybody a red pen. And I tell you to write in red ink, print everybody's first name, middle initial, and last name, fold it in half, and put it in the goldfish bowl that I have here and at the Oconee campus. Does everybody have the same chance of being picked?
Yes.
Yes. Well, let's say Mr. Robinson, which he does things, he doesn't follow directions very well because he was in the Navy. Okay? He'll say that he decides to fold his, he doesn't use the red pen, he uses a black Sharpie, and he folds his up into 8 folds. Is it still a random sample? Not really. Because why? Because the person that's drawing out of the fishbowl will be influenced by that harder fold. Okay? Or they may see, when they're looking, they may see that black marker and they may be influenced not to pick it or to pick it. The same thing with the fold. So when you mess up, and it's real trivial. Some of y'all may say, well, that's trivial. Well, when you're dealing with statistics, you have to be just like an umpire. What is an umpire?
Rule maker.
Right down the what? Has to be right down the middle. He has no judgment because of he likes this team, or he has no judgment because of this, or he has no judgment because of that. I really found out about judging when I went through a divorce. Okay? Those judges, they have to be right down the what? Middle. And I'm going to tell you something. I knew the judge I knew that judge. We had met. We've been on several committees together. And that judge was as down the middle as you could get. All right? I could not believe how down the middle that judge was. All right? So anybody that says that a judge or an umpire is biased, they really have to look hard, because the experience I had with that judge was, there is bad judges and bad umpires out there, just like there's bad cops, but we're not talking hopefully not a big population. But what I'm trying to tell you is, statistics has to be just like a judge or a umpire. It has to be what? Right down the middle. So when Mr. Robinson folded that paper up, it might not help him getting picked. It may what? Hurt him from getting picked. It may go both ways. The person that's putting their hand in that cookie jar or that fish bowl to pick, they may see that and they shy away from it. Well, that's hurting his chances. They may grab it because it's folded different. That's helping his chances. Either way, it's biased. Either way. So even though it's something as very small as folding a piece of paper, it is sending a message right or left of what? The middle. Now, right or left in statistics is not political. Right or left is throwing the scales off what? Balance. So when I say right or left, that's right or left of middle, and that's what you're supposed to be in statistics. Write down this. And it's in, oh, forget it. Middle is paramount. Okay? Now that goes with the midpoint, the median, the average. Everything is compared to the middle in statistics. Everything is compared to the middle. So if you're in the middle, that means you're not biased either way. That's why everything is compared with the middle in statistics. Okay, what if I was to go through and sit outside the parking lot and not sit outside the front doors? I don't know about the Oconee campus or the Easley campus. Easley campus, I think y'all only have one entrance, right? Oh, Oconee campus. Y'all have one entrance to the building?
Yes.
Yes.
That's because of security reasons. All right. So you sit outside the Oconee campus and you ask every seventh person if they are in the Marlboro Club or not. Okay. That is called a systematic sample. Why is it systematic? Because you're asking every what? Seventh person. Systematic. Write that down. Systematic. Every what? Nth item. In other words, you can't say, okay, well, I'm going to ask every seventh person. Okay, I don't want to ask these last two people, so I'm just going to go with this person, and no, you can't do that. If you do every seventh person, you have to wait until the last person is out of the building. You can't just stop halfway through and say, I'm just going to ask the last person. I've asked 14 people. I'm just going to ask the last person. No, you can't do that. If you're setting it up as a systematic, and that's another thing, consistency. When you're dealing with probability and statistics, consistency is right there with being non-biased. Consistent and down the middle. A cluster sample. A cluster sample would be like, just put cluster sample, put voting precinct.
Put what?
A voting precinct. Why is that a cluster sample? Because you have to vote at a certain what?
Place.
Can you go over to 2 or 3 counties over here and vote? No.
No.
You have to vote where you what? Where you are a voter in your precinct. Okay? So everybody on election day that votes will be at one certain place. They may not think the same. They may be Democrat, Republican, Independent, Libertarian, Tree Hugger, Greenpeace, whatever that is, environmentally or environmental party or whatever. Okay? They're all there because, not because they want to be there, they're there because that's where they have to be to vote. So that's a cluster. A voting precinct is a good example of a cluster sample. So if I wanted to go out and ask those people, did you eat beef have you eaten beef today? Then that would be a cluster sample because they have nothing in common except that they're at that place because they have to be, because that's where they vote. Okay, because that's a cluster sample. A stratified sample would be inside that cluster sample divided up into what? Certain things like Democrat, Republican, Independent, or what? Women, men, race, religion, or income. Now, of course, I wouldn't probably do some of those because they really don't have anything. I probably would go in and say men and women, white or black, or red, yellow, black, and white. You know, the old song goes. I would put different colors, okay? But I probably would not do religion or income. I mean, that's getting a little bit nosy, okay? But it's kind of hard not to be nosy unless you walk up to some people that think they're a color that they're not, which I'm not going there. Dang old woman, dang old, Schubert, shut up. Okay, so I will go here and I'll say that if I go to a voting precinct, okay, I'm going to divide these people up into three categories. I'm going to divide them up whether they're Republican or Democrat or independent or libertarian, and I'm going to decide if they're male or female, and then I'm going to do red, yellow, black, or white. And I'm going to decide what they are or other, okay? So that's something I would do. And of course, the race would be written the way they are on forms. I don't know what they are. Caucasian, non-Caucasian, other, black, Asian. I don't know why they don't have dang old drunk Irish on there. I would check that if it had drunk Irish, but they don't have that on there. All right. That was supposed to be funny, but y'all didn't think it was funny. Convenient sample. What's a convenient sample? Well, let's say that I worked at a radio station that only played 80s rock music, which is the best rock there is, next to the 60s. It's the best rock there is, okay? 80s rock. And I decide to send out a sample over the airwaves. I'm a DJ, so I get on the DJ and I said, I want y'all to call in. I'm going to take a survey right now of people that like rock music. What's wrong with that? I want y'all to interact with me. Mr. Robinson, what's wrong with that?
Being biased?
No. Well, why? Why am I being biased?
You're only obtaining information from them.
You're not going to a country radio station and asking if they like rock.
Okay, I'm working at a what? I'm working at a rock station, and I'm doing a show that plays rock from the 80s, and I'm calling out to the people. I say, let's call in right now. I'm taking a survey. How many of you like rock music? Well, what's the answer going to be?
Everybody that's listening.
Everybody that's listening. That's a convenient sample. Least accurate, least reliable. Convenient sample is hollering out your window of your apartment and asking people that are walking by, are you a health nut? Okay, most of the time when people are walking, they're either walking their dog, they're walking to work, or they're walking to the store, and instead of walking, either they don't have a car or they're wanting to be a little bit more healthy, one of the two. Or it's right near their house or whatever. The whole point is you can't just ask a question and say, okay, this is valid. You've got to think about what you're doing when you're doing statistics. You've got to think about how you ask the question, where you ask the question, and what kind of population or what kind of sample you're actually asking. Okay, I'm not going to go through this. That's every 20th. When you see every 20th or every 7th or that is what? That's a systematic. I'm not going to go through these, but place in a bin and all tickets are mixed up. That's a random sample. Children in a large city are classified based on the neighborhood school they attend. Okay, that would be a cluster. And then they divide it up into male and female or something like that. That would be, okay, the first 50 people interviewed are asked if they support an increase in taxes to support. That would be a convenient sample because you just ask people walking in. And, okay, registered vehicles, that's a cluster. Write that down. Registered vehicles in this question, that would be highlighted and you would call that a cluster. But within the cluster, they ask you what? Subcompact, full size, mid-size, compact, go-kart, whatever. They break it up into more what? Subgroups. Just like if I was to go to the cluster sample of a voting precinct and ask male or female or gender, race or whatever. I'm breaking I'm breaking the cluster into subgroups, and that would be a what? Stratified. Many individuals, businesses, and advertising firms misuse statistics to their own advantage. No. I'm going to tell you this story. What time is it? Because I don't want y'all going into, hyper.
157.
Whatever. Okay. We've got, what time's class over? 2:10 or 2:15? What time is class over?
10. 10.
Okay. Misuses of statistics. When the primaries were going on, and I was looking for some examples of polling during the primaries of 2016 election. About the third or fourth debate, they had found out that Jeb Bush was not going to be the next president of the United States, or the next nomination, because he was getting like 2% of the vote from the first 2 or 3 primaries, and they basically wrote Jeb Bush off. So they were looking for another person because Trump couldn't be president because he just wouldn't be a good president because he's not a politician. So this is what they did. Right before the third debate, some of y'all might remember this. Before the third debate, now I'm not talking about the general election, I'm talking about the Republicans, the 17 Republicans that were, 18 Republicans that were running, all right? There was a poll that came out right before the third debate. The third debate was like on a Friday night or whatever, or a Saturday night. I think it was on Saturday night. Third debate was on Saturday night. Or it might have been on a Saturday night, yeah. And this came out on Friday. This Friday poll came out. And that Friday poll said that 56% of Americans believed that Ted Cruz was going to be the next nominee. Now, as a statistician person, I'm not going to call myself a statistician because I got a math degree, so I'm not going to call myself a statistician. But I will say that as a math teacher, I was watching these polls. And at that time, when this poll came out, Donald Trump was leading anywhere from 22 to 25% of the Republicans. There was 18 Republicans. So, of course, he wasn't going to have a very high amount because there was 18 of them. The 17 that he beat out, okay, because the Russians told us who to vote for, okay? Mm-hmm. The 17 Republicans that he beat out, he was running about 22 to 25%. And then where did this poll come from? 56%. Well, I looked at that poll, and I went to the polling website. I can't remember the name of it right now. But I went to the polling website, and this poll was there, and it was the only one that had 56%, so I pulled it up. Do you know what N was? N was like 500 people, and the margin of error was like 8 to 9%. Okay, why did you laugh? Why did you laugh? I'm asking you, there's a reason that you laugh. Why?
It just seems so fake.
That's what it was. This was called a political hit job. Okay, why? Do you know what an oppressive poll is?
No.
Anybody know what oppressive polling is? It's a poll that is meant to make you change your what?
Mind. To convince you to something.
I'm sorry, what?
To try to convince you to believe something else.
Exactly. You need to write that down because that's what an oppressive poll is. An oppressive poll is used to make you think another direction. And what was happening was, this was happening, and that wasn't what was wanting to happen. Because Jeb Bush had already lost, he'd lost it. Because he'd been 3 or 4 primaries, And he spent like $25 million in New England or whatever up there in that primary or whatever that primary was up in the New England states. And he lost. He only got like 1%. So he was toast. So the Republican Party was looking for somebody because they couldn't have Trump because he would destroy everything. Okay? So they had to find somebody. So what they did is they said, okay, we're going to put this poll out here. Now, I don't know who did it. I don't know who did the poll. Okay? But the whole point was they thrust that thing out there to say, okay, Ted Cruz is going to be the next nominee. And what would that do to the person voting at the next precinct or the next primary? Oh, well, I don't think Trump's going to win, so we'll just vote for Ted Cruz. That's called an oppressive poll, and they use it very much. And do you know that not a single, now the other thing, if you get a poll and the margin of error, okay, that's nice. The margin of error is greater than 3%, you might as well take that poll and put it under the birdcage because it's not worth anything.
Why would they not average it to like 100 instead of 500?
Huh?
Just to mess with you?
That's what we're fixing to do right now. This right here is worthless. You're talking about a national poll. A national poll, and they only interviewed 500 people. They should have interviewed 5,000. Okay?
Yeah.
National poll. If you're going to put a poll out nationwide, you better ask at least 1,000 to 5,000 people. And they better be from different states, and they better be from different parts of the area. Okay? This was a political hit job. This was a oppressive poll. Not a single poll after that looked like that. Not a single poll before that looked like that. That was put out there to sway voters. Okay? That is a prime example of a misuse of statistics. And you probably can think of other things that you've seen on TV or, like you said, cigarette industry, using fake numbers. Yes, it happens. That's why knowledge is what? What's the old saying about knowledge?
Knowledge is power.
Knowledge is power. Ignorance is controlled. Okay? So make sure you realize that. Was the sample used to gather the statistical bias? Was it biased? That's when you get the questions. That's when you get the questions that say, you're not going to vote for this person in the next election, are you? Well, you can't do that. You can't say that. Was the sample used to gather the statistical data unbiased? Is the statistical statement ambiguous and would it be interpreted more than one way? So, a lot of things right down the middle. 4 out of 5 dentists recommend sugarless gum for their patients who chew gum.
I've heard of this one.
In this advertisement, we do not know the sample size and the number of times the experiment was performed to obtain the desired results. That's a Trident commercial. I remember that.
Mm-hmm.
The advertisement does not mention that possibly only 1 out of 100 dentists recommend gum at all. In an advertisement for golf balls, a driver golf ball is hit and another brand golf ball is hit the same manner. We are told that the driver golf ball travels farther, and we are supposed to conclude that the driver golf ball is a better golf ball. If you want to know if you want to know something, all golf balls are pretty much what? The same. Just like baseballs. The advertisement does not mention the number of times the experiment was previously performed or the results of the earlier experiment. Wind speed and direction. No two swings are identical. The ball may land on a rough or smooth surface. You ever seen Tin Cup?
Yep.
Great movie. Great movie. What does the guy bet a tin cup at the beginning? He says, I bet you I can hit a ball so many yards, the longest, with a 7-iron. And Tin Cup gets over there and he hits it. He puts it right there and he hits it toward the sign. 220 yards. Boop. Okay? What does Don, what's his name, do? What's his
Mexican
name?
cat in there?
Don Johnson. Don Johnson turns and hits the ball down the what?
The road.
The road, and it goes like 500 yards. Okay? Again, we didn't tell you that. He hit the ball the longest, but he didn't hit it down the what? Down the driving range. Same thing here. The ball may hit the flat surface and keep what? Still going. That's what Don Johnson says. Still going. You got to watch yourself with statistics. Vague or ambiguous words also lead to statistical misuses. The word average is one such culprit. There are at least 4 different averages, some of which are discussed. Each is calculated. Let me check the time because some of y'all are starting to fade out on me. It's 2:08. We need to quit. Let's see how many slides we got. Yeah, we need to go ahead and finish. We'll pick up in 12.1. We'll finish these slides come Wednesday.
Yes.
What do y'all need to work on? The test?
Test homework.
Test
All
homework.
right. Y'all be good and have a good day.
Too. Thank you.
I can't cut off the recording. I click on it and it doesn't do anything.